Welcome to this explainer on the 2026 laser sourcing landscape. Now, if you're a purchasing manager dealing with metal, plastic, or composite parts, you're definitely going to want to listen up. We're diving deep into the exact intelligence you need to strategically drive down your cost per part and, crucially, dramatically shorten those lead times.
So let's just start with the elephant in the room, right? Why are your metal parts constantly delayed and over budget? I mean, we've all been there. You send out an RFQ, the pricing looks pretty good, but then the deadlines just start slipping, the defect rates climb. Choosing the wrong laser supplier doesn't just mean getting a few bad parts. It creates this huge, devastating domino effect. We're talking missed production deadlines, totally inflated unit costs, and absolute bottlenecks in your supply chain.
Okay, so here's our buyer's blueprint for today. First, the sourcing landscape. 2. Fiber versus CO2 lasers. 3. Workflows that cut costs. 4. AI and fast lead times. And finally, number 5. Mitigating sourcing risks. Let's get into it.
Section 1. The laser sourcing landscape. The market ecosystem.
Look, in 2026, sourcing is no longer just about knowing what a machine does. It's really about how that specific application impacts your vital KPIs. A generalist shop, sure, they might get your job done eventually. But partnering with specialized manufacturers, the ones who tailor their tech to your exact sector, that is the absolute secret to hitting those super aggressive pricing and lead time targets. When they specialize, their setup costs drop, their efficiency completely skyrockets, and the best part, those savings get passed directly to your bottom line.
Section 2. Fiber versus CO2 lasers. The technical baseline.
So let's break down the massive difference between these two technologies. On one side, we've got fiber lasers. These use solid-state diodes, which makes them incredibly fast, highly cost-efficient, and just absolutely perfect for metals, even the highly reflective ones. And because they have inherently low overhead, suppliers running fiber can offer you much more competitive unit pricing, especially for high volumes. But then, on the flip side, we have CO2 lasers. This older tech relies on a gas mixture. It's highly specialized and, honestly, vital for organics and polymers like acrylics. But here is your sourcing reality check. If your supplier is using a CO2 laser to cut intricate sheet metal, you're basically paying for their inefficiency. They will seriously struggle to meet your lead times and pricing expectations compared to a shop fully equipped with fiber.
At the end of the day, the material dictates the machine. Say you're sourcing carbon steel. You'll want to specify a fiber laser with oxygen assist. It's a low-difficulty, pretty much commodity process, but just be on the lookout for rust on the edges. Need super clean, burr-free stainless steel? You've got to have a fiber laser with nitrogen assist. But take a look at polycarbonate right there at the bottom. It has a really high difficulty rating and risks severe charring under a laser. So in that case, a traditional CNC router is actually way cheaper and just a better choice all around. Translating these technical specs into actionable sourcing data means you know exactly what defects to anticipate and exactly which processes to demand way before you ever sign that PO.
Now, if you happen to be procuring highly reflective metals, think copper or brass, you absolutely must ask your supplier this exact question during your audit. Does your fiber laser have back reflection protection? Seriously, write that down. Standard lasers without this protection can literally be destroyed by the reflected beam just bouncing right back into the lens. And what does that mean for you? Catastrophic machine failure, massively expensive downtime, and ultimately severely blown delivery dates for your parts.
Section 3. Workflows that cut costs. Beyond the machine.
Okay, the very first workflow you need to audit is their nesting software. Think of it kind of like cutting cookies out of rolled dough. Nesting is how their CAD/CAM software optimally packs your specific parts onto a raw sheet of metal. And asking a supplier about the efficiency of this software, that directly translates to your bottom line. Why? Well, because you're the one paying for the raw material. If their software is outdated, you are literally paying for the wasted metal left behind on their cutting table. No way around it.
Beyond just the software, you've really got to audit their facility infrastructure. Are they running bulk liquid gas systems, or are they out there just swapping out individual cylinders? Bulk gas ensures consistent pressure, and that means uniform edge quality for your entire batch. Simple as that. And what about secondary operations? Finding a true one-stop shop with in-house deburring and CNC bending drastically reduces your logistics costs. Plus, it totally prevents suppliers from pointing fingers at each other when quality disputes pop up. Oh, and finally, don't just trust their precision. Verify it. Are you requesting CPK capability reports to account for things like thermal expansion on thicker materials? If not, you definitely should be.
So your pricing strategy absolutely has to align directly with your volume. If you're a smaller buyer or maybe an e-commerce seller, you should definitely leverage platforms like Xometry or maybe local job shops. You'll avoid those pesky minimum order quantities and get some really great kitting services, though, you will inevitably pay a slightly higher per unit cost. But if you're a bulk buyer or an OEM, you need to demand total transparency. You've got to move upstream to contract manufacturers and negotiate based on the machine hour rate plus the material cost, rather than just blindly accepting flat per piece rates.
Section 4. AI and fast lead times. 2026 automation.
Right now, the absolute gold standard suppliers out there are running what we call lights-out manufacturing. Basically, this means their factories have fully integrated automated loading and unloading. This allows their lasers to just run 24/7, literally in the dark, with virtually zero human labor. If you're a bulk buyer who needs massive volumes delivered on impossible deadlines, this exact level of automation is what's going to guarantee your lead time.
And supporting those crazy 24/7 cycles are AI vision systems and IoT predictive maintenance. You can really think of these technologies as the ultimate insurance policies for a supply chain manager. AI systems are inspecting parts in real time right as they're being cut. They catch defects instantly, so a faulty batch never even makes it onto the shipping truck. Meanwhile, IoT-connected lasers are constantly monitoring the machine's health to virtually eliminate unplanned downtime. Working together, they relentlessly protect your delivery schedule.
Section 5. Mitigating your sourcing risks. Sourcing strategies. Okay, here is your exact mental checklist for your very next supplier negotiation. First up, manage the heat-affected zone, or HAZ, which can actually make metal edges dangerously brittle. You can mitigate this by explicitly specifying nitrogen assist in your RFQ to ensure a cooler cut. Second, prevent molten dross and burrs from ruining your parts by setting crystal-clear acceptable quality levels, or AQLs, right there in the vendor contract. And third, you've got to stop suppliers from secretly substituting lower-grade steel just to pad their own margins. Demand material test reports, or MTRs, with every single shipment. Don't compromise on that.
So to kind of wrap up our explainer today, here are the 4 critical pillars you absolutely must lock down before issuing any laser cut part RFQ. You want to start by verifying the material match. Ensure that the thickness and the alloy type completely align with whether the supplier uses a fiber or a CO2 setup. Then, confirm your exact tolerance requirements so you're not overpaying for precision that you honestly don't even need. Next, critically assess your actual volume against the chosen process. And lastly, formally clarify exactly who takes on the responsibility for post-processing tasks, just so nothing falls through the cracks.
I want to leave you with one final, kind of provocative thought here. Lasers are incredible. They're highly precise, they're extremely fast. But if you are ordering hundreds of thousands of units, is your high volume actually justifying laser cutting? Or would the higher upfront tooling cost of metal stamping actually be significantly cheaper per unit in the long run? It's a fundamental question that every strategic purchasing manager should be aggressively asking to push for maximum cost optimization. Thank you so much for joining me for this explainer, and hey, happy sourcing!